Okay, we're going to continue with the 5.6 day one notes with number 8, which is the limit as x approaches 0 from the right of x cubed times cotangent of x. So the first thing we want to do is plug in 0. So I'd have 0 times the cotangent of 0. Now this is where this one might get a little bit difficult because you may not remember what the cotangent of 0 is. It's undefined, but we need to know what does it shoot towards. So if you remember, and if you don't remember, you can always graph the cotangent on your calculator. The cotangent graph and the tangent graph look like this. That's cotangent. Tangent goes the other way. And then there's an asymptote there. And when you were graphing these in pre-calc, you looked at, for the most part, you looked at one fundamental cycle, and this is one fundamental cycle, starting at 0 and going towards pi. And so if you look at the cotangent of 0, this is 0 right here. You can see the cotangent of 0 is shooting up towards infinity. So this would be 0 times infinity, because the cotangent of 0 is infinity. And that is an indeterminate form. So you can do L'Hopital's. Now the problem here, or another problem, is in order to do L'Hopital's, I have to have a fraction. And I don't have a fraction here. But I could rewrite this as the limit as x approaches 0 from the right of x cubed over tan x, because that's essentially 1 over tangent x, which is the same as cotangent x. And then I can take the derivative of the top, which would be 3x squared, and the derivative of the bottom, which is secant squared x. And then plug in 0. And if I get 0, plug in 0 on the top, I get 0. And then if I plug in 0 on the bottom, I'm looking for the secant of 0. And the secant of 0 is actually 1. And 1 squared would be 1. So this is 0 over 1 squared, which is 0. So the limit of this guy is actually 0. All right. Okay, so let's go to the next one. So if I plug in infinity here, I would get infinity times the tangent of 1 over infinity. And the tangent of 1 over infinity would really be the tangent of 0, because 1 divided by infinity is 0. And the tangent of 0 is 0. So this would be infinity times 0. And that is an indeterminate form. So I can do L'Hopital's on this one. Okay, now my two terms are x and tan 1 over x. Those are my two terms. And so technically, I don't have a fraction on this one either. I mean, I know I got 1 over x, but that's part of that term. That's not a fraction. So I need to rewrite this. I'm going to rewrite this as the limit as x approaches infinity. I'm going to leave the tan on top, so tan of 1 over x. And then I'm going to take that x, and I want to move it down to the bottom, and I can do that by just saying x to the negative 1. That's the same. Okay, then I'm also going to rewrite this as tan x to the negative 1. That's the same as well. Okay, so then so we already know we got an indeterminate form, so we'll do the derivative of the top. The derivative of the top, so it'll be limit as x approaches infinity. Derivative of the top is secant squared. of x to the negative 1, and then I have to chain rule that, so that would be negative x to the negative 2, and then the bottom would be just negative x to the negative 2, which is nice because that essentially those cancel each other out. So I've got really I got secant squared of 1 over x. That's what that was simplified to. And if I plug in infinity here, it would be essentially secant squared of 1 over infinity, which would be 0. And the secant of 0 is actually 1, so that'd be 1 squared, which is 1. So the limit here is going to be 1. So the limit of that function is 1. All right. Okay, so this one, if I plug in infinity, I'm going to get 1 plus 1 over infinity, which is 0. And then, so this would be 1 plus 0 to the infinity, which is really just 1 to the infinity. All right, that was not a coronavirus cough. I just got some allergies. So 1 to the infinity is a indeterminate form. I know it seems like it should be 1, and it might be, but we'll see at the end of this problem if, in this case, 1 to the infinity is actually 1. Okay, so whenever we had that exponent as a variable, one of the techniques that we used a while ago was to take the log of both sides of the equation to get that exponent out of that power position, because that's one of the properties of logarithms. But we don't have another equation, so we're going to set y equal to the limit as x approaches infinity of x, or no, of 1 plus 1 over x to the x. Okay, so all I've done there is throw in a y to make it an equation so that I can take the log of both sides. So I'm going to take the log of y, and then I'm going to take the log of this. So it'd be the limit as x approaches infinity of ln, and I'm purposely leaving a spot there because that's where that exponent is going to go. 1 plus 1 over x, and then I'm going to take that exponent and I'm going to stick it out front, so that becomes x right there. Okay, so hopefully you followed that. Then I'm going to essentially rewrite this side. So if I plug in infinity here, I'd have infinity times the natural log of 1 plus 1 over infinity. And the natural, so that this part right here, 1 over infinity, would be 0. So this is really just going to be the natural log of 1. Natural log of 1 is 0. So this is really infinity times 0, which is one of our indeterminate forms. All right, so I'm going to rewrite this very similar to the last problem. So I'm going to do the limit as x approaches infinity, and I'm going to do the natural log of 1 plus, I'm going to rewrite that as x to the negative 1 over, and then I'm going to take this x to the negative 1, or this x, and make it x to the negative 1 so I can have my division. Okay, so Now, I can do L'Hopital's on this thing right here. All right, so we're going to do the limit as x approaches infinity. We're going to do the derivative of the natural log of 1 plus x to the negative 1. And we know the derivative of any natural log is 1 over 1 plus x to the negative 1. And then we got a chain rule, the 1 plus x to the negative 1. The derivative of 1 is 0. The derivative of x to the negative 1 is negative x to the negative 2. And then we're going to divide that by the derivative of the bottom, which would be negative x to the negative 2. All right, so again, if you get confused here, pause it, look at it, see if you follow it. All right, good news is I can cancel those. All right, and so all I got left, see if I can squeeze this in, is 1 over 1 plus, and I'm going to rewrite that as 1 over x. Okay, so if I plug in infinity now, I'm going to get 1 over 1 plus 1 over infinity. And we know that is 0. So this just becomes 1 over 1, which is 1. All right, now that's not the tricky part. So that is not equal to the limit. And I know somebody out there is saying, what, dude, I know you are. You're saying what that's equal to. That's not what y is equal to. That's what natural log of y is equal to. So the natural log of y is equal to 1. I want y, and we've done this a million times. We know we're going to do e to the, and this becomes y equals e to the first power, which is just e. So my limit is e. So essentially, in this particular problem, 1 to the infinity is the number e, which is about 2.72. So that's what I was talking about. It's not, the indeterminate form is not intuitive. If you asked anybody on the street what 1 to the infinity power is, I guarantee you they would all say it's 1. But in this case, it's not. It's 2.72. Okay. I think this is the last one. Yeah, good. Thank God. All right. So if I plug in 2 here, I'm going to get 1 over 0, and I'm going to be divided by 0 there also. So you can't do straight substitution. All right. But if I look at this, and actually this is kind of silly to do it this way because there is a common denominator. So I could write this as a single fraction, but I want to show you one of the other indeterminate forms. So if this was a real problem, you'd write it as a single fraction and go from there. But if I plug in to like something a little bigger than 2, because it's approaching 2 from the right, so 2.1, so that then I'm going to get 1 over a number a little bigger than 4 minus 4, which is going to be a small number. So that's going to be 1 over a really small number, and it's a positive small number, minus. And if I plug in a number a little bigger than 2 into the numerator here, that's going to be something really close to 1. And then on the bottom, it's going to be a really small number again. So this is 1 divided by a small number is infinity, and 1 divided by a small number is infinity. And so in this case, we have infinity minus infinity, which is indeterminate. I know, again, it seems like it should be 0, because anything minus itself is equal to 0, but weird things happen when you go towards infinity. So let's see if this is 0 or not. Okay, so then I am going to rewrite this with a single denominator. So the limit as x approaches 2 from the right. And then this would become 1 minus the square root of x minus 1 all over x squared minus 4. Okay, so if you did substitution here, you would get 1 minus 1, so 0 on top, and you get 0 over 0. So you could do L'Hopital's on this if you wanted to, and it would work. But actually, I think I'm going to do the conjugate. I'm not exactly sure why I'm doing this. I think it might be easier. That's my choice. I can use whatever method I want. So I'm going to multiply by 1 plus the square root of x minus 1 over x, no, 1 plus the square root of x minus 1. Okay, so that was from first semester, also from pre-calc, so you should remember that, multiplying by the conjugate. And then on the top, that's going to give me 1, and then the middle terms are going to cancel, and then I'll get minus the quantity x minus 1 over, and then don't distribute here. So we got x squared minus 4 times 1 plus the square root of x minus 1. Okay, so on the top, I would get negative x So I got 1 minus, so I'm going to change this to a plus, this to a minus, this to a plus. So I'm going to get 2 minus x over this, x squared minus 4 times 1 plus the square root of x minus 1. Okay, so if I plug in 2 now, something a little bigger than 2. So if I plug in something a little bigger than 2 on top, I'll get, well, let's talk about 2 first. So if I plug in 2, I'm going to get 0 divided by 0. So that would be L'Hopital's rule. All right, so we can do L'Hopital's on this one if we want. Oh, you know what? I just noticed something that's better than that. Let's not do L'Hopital's rule. Let's do 2 minus x over, I just noticed that this is factorable. So that's factorable to x plus 2, x minus 2. Yeah, I like this better. Times 1 plus the square root of x minus 1. All right. Yeah, that's going to work out nice. So the 2 minus x and the x minus 2 are not exactly the same. We can cancel them if we put a negative 1 on top. All right, so I got negative 1 over x plus 2 times 1 plus the square root of x minus 1. All right, yeah, that'll work out much better. Okay, so on top, I got a negative 1. On bottom, I can do straight substitution. So if I plug in 2, that's going to give me 4. And if I plug in 2 here, that's going to give me 2. So this is actually negative 1/8. All right, so in that particular problem, infinity minus infinity is actually negative 1/8. And what that means is the two infinities are really close to each other because it's almost 0. So if the infinities were going towards infinity at the same rate, then it would be 0. But it appears that the negative 1 is going just a little bit faster. And the reason why I know that is because my answer was negative. So that means the negative won out. So if I take this number minus this number and I get a negative, then this one's a little bit bigger. All right. And since it's negative 1/8, it's so close to 0 that they're really close to each other. But here's a case where 0 minus 0 is actually negative 1/8. Okay, so I am going to post the homework. I'll do it on portals and I'll do it on GroupMe. Let's stay in contact. If you have questions, let me know. On Thursday, we're going to go live. I'm going to do a video that we meet during our normal classroom time, and we'll talk about some stuff. We'll go over questions, but I need everybody to be online that particular day on Thursday when our class would normally meet, and that's a day one. So we would normally meet at 12:50. So that's the time that everybody needs to be online. I'll send the link out via GroupMe, and we need to do it on Thursday to make sure that this is going to work and that everybody's able to watch it and share in it. So make sure you do that on Thursday. And again, I'll be in touch.